Hey there! Let's begin today with a very interesting problem. Imagine you're at a fair and you want to ride the giant wheel and play hoopla. The number of times you played hoopla is half the number of rides you had on the giant wheel. And if each ride costs 3 rupees and a game of hoopla costs 4 rupees, how would you figure out how many rides you had and how many times you played hoopla, given that you spent a total of 20 rupees? This is where we use something called linear equations in two variables, which we will now explore. Let's dive into the graphical method of solving a pair of linear equations. A pair of linear equations is just a system of two equations, each with two variables, let's say x and y. The solution to these equations is simply the point where the two lines representing these equations meet on a graph. In the graphical method, we plot both equations as lines on a graph. And the point where they intersect gives us the solution. Now, there are three possible scenarios here. The lines can intersect at exactly one point. This means the system of equations has a unique solution. The lines might not intersect at all. This happens when the lines are parallel. When this occurs, we say the system has no solution. The lines could coincide, meaning they overlap completely. This situation gives us infinitely many solutions. Let's now break down these three possibilities a little further. Unique solution: if the lines intersect at one point, we have a unique solution. No solution: if the lines are parallel, meaning they never meet, the system has no solution. Infinite solutions: if the lines coincide, meaning they overlap, we have infinitely many solutions. For example, consider the equations 1, x minus 2y equals 0 to 3x plus 4y minus 20 equals 0. In this case, the lines intersect at a single point. So, this system has a unique solution. Now, let's see another example. 1, 2x plus 3y minus 9 equals 0 to 4x plus 6y minus 18 equals 0. Here, the lines are actually the same, meaning they coincide, giving us infinitely many solutions. Let's try solving a pair of equations graphically. Consider the system 1, x plus 3y equals 6. 2, 2x minus 3y equals 12. To solve this graphically, we find a couple of solutions for each equation and plot them on a graph. For the first equation, when x equals 0, y equals 2, and when x equals 6, y equals 0. For the second equation, when x equals 0, y equals negative 4, and when x equals 3, y equals negative 2. Plot these points on the graph and draw the lines. The two lines intersect at the point 6, 0, which is the solution to this system of equations. So, x equals 6 and y equals 0 is the unique solution. Now let's consider another example where the equations have infinitely many solutions. 1, 5x minus 8y plus 1 equals 0. 2, 3x minus 24y plus 3 equals 0. We can simplify the second equation and find that it's essentially the same as the first equation. When we graph these two equations, we see that the lines overlap completely. This means that every point on the line is a solution to the system, and so we have infinitely many solutions. This is an example of coincident lines. Let's quickly revise what we've learned today. We explored how the graphical method helps us find the solution to a system of linear equations by plotting their lines on a graph. Depending on how the lines behave, whether they intersect, are parallel, or coincide, we can determine whether the system has a unique solution, no solution, or infinitely many solutions. The graphical method is useful and intuitive, but sometimes, especially with complex numbers or non-integral solutions, we might prefer other methods. In the next video, we'll look at algebraic methods like the substitution method and elimination method, which help us solve systems of linear equations with greater precision. See you then.